All right, chemists, today we're going to learn how to read the solubility table that is in your reference packet. So everybody should take a second right now and get your reference table out and turn to the solubility table. So when you're looking at a compound, it's going to be an ionic compound, meaning all of our elements in the first position are going to be metals. So you're going to look in the column here, and these are all going to be metal cations. So when you're looking at an ionic compound, you're going to identify what the cation is. And notice some of the cations are the same metal but have different charges. So let's just pick a random compound. We're going to do several random compounds here. I'm going to start with some compounds that we know. First one is sodium chloride, and that's table salt. And you probably already know what happens to table salt when you put it in water. It dissolves. So let's find sodium. You run your finger down until you find sodium in the cations. And then we're going to go over until we run into chlorine. So at the intersection of sodium and chloride, there's a big S. So what I want you to do is find the key down here. Big S does not stand for solid. It actually stands for soluble. So soluble in cold water means that when you put it in water, it's going to dissolve. So the state of matter is going to be dissolved in water, or AQ. So put that in your key so you can reference that in the future. That means the state of matter of sodium chloride in a double displacement reaction is going to be AQ. Let's try another compound. Potassium nitrate. So let's identify our cation. It's going to be written in the first position, and it must be a metal. So you're going to run down the list of cations, which is on the left-hand side here. You're going to find potassium, and you're going to go over to nitrate. Also has big S, so that means that is soluble. So you're going to write AQ. That leads us to a couple patterns. Notice that all sodium and all potassium and all nitrates are soluble. That means any compound that starts with sodium or potassium is soluble. Any compound that ends in nitrate is also soluble. Okay, let's do a couple other compounds. Remember silver chloride? Silver chloride was one of the compounds that we did a demo with. So let's find silver here, and let's go over to chloride, which is right here. You'll see an I. So you already have AQ written down for big S. I says insoluble in cold water. That means it's not going to dissolve. That means that when you put it in water, it's going to stay as a solid and not dissolve. You saw that solid in solution. That was called a precipitate. After that, you're going to write S for solid. So anytime you see an I, you're going to think insoluble. So you can see there's a bunch of them over here that are mostly insoluble, which are like the phosphates. There's a couple exceptions, which are sodium, potassium, and ammonium, and chromate. Couple exceptions there for chromate, but mostly insoluble. Notice the exceptions are the ones we already talked about. Another one that is soluble in cold water all the time is ammonium. Let's do another one. How about lead plus 2? And let's run over to sulfate. All the way over here, and you get to sulfate, and you'll see it says I. So that means it's going to be a solid. So lead sulfate is going to get an S for solid. It will not dissolve in room temperature water. Last thing we're going to go over is this S, the small s. So small s like this, like strontium hydroxide. We're not going to worry about slightly soluble right now. So you're going to put solid next to slightly soluble. That means it doesn't really dissolve all that well. So you're going to have AQ for big S, S for little s, S for I, and decomposes we're not going to worry about right now. We're not going to deal with those compounds. That's another thing going on altogether. So this is how you read a solubility table. I'm going to summarize here. Whenever you see a compound, it has to be an ionic compound to use the solubility table. So you have a cation in the front. So if you notice, if it's not ammonium, you're just looking for the first element. So whenever you see a compound, let me just come up with one randomly. This is nickel acetate. You're going to know that the first element, if the first element is not a polyatomic ion of ammonium, then this is going to be your cation, and the rest of it is going to be your anion. These are only for ionic compounds, and this solubility table is only going to be used for double displacement reactions. The only one you're going to need the solubility table for our purposes is going to be the double displacement reactions. So don't try to use this with anything but ionic compounds to tell whether they're soluble in water or not. Double displacement reactions are always going to have water present, so that's all we're going to use it for.